So far we have seen that while applying font size or padding, margin or maybe a dimension or angle, we use some or the other unit with the value. For example, font size 12px, here px is the unit which stands for pixels. Another example is width is equal to 100%. In this case, percentage is the unit with the value. Like px or percentage, we also have various other units. For example, you may apply width using px or even cm, that is centimeters, like width is equal to 34 pixels or maybe 3 cm. Working with units is an easy task, but CSS offers various options of units which you can use as per requirement or for the best suitable situation. CSS provides us with lots of units, some of whose values are fixed, generally known as absolute units, while there are others whose values are relative to other values, like a child element's value is dependent on the parent elements or to the default value of a particular HTML element. These are called as relative units. These two are major types of units in CSS, as each of them provides a wide range of length values. So let's dive into this section and take a closer look at various CSS units available. The px unit is the magic unit of CSS. It basically stands for pixels. This unit is mainly designed for CSS and is the most widely used absolute length unit. Pixel is a fixed unit measurement, as it is an absolute length value and is also the smallest unit on screen measurement. So let's directly see some practical implementation using the unit pixel. I'll start by creating a division and I'll pass a message inside. Now to style this div, I'll start with background color. We'll give text color. Let's also center align this text by giving text align. I will also increase the font size to 50 pixels, and you can see the area of the division also increased in the context with the font size. Generally, 1 pixel equals the 96th part of 1 inch, that is 1 by 96 inch. So 50 pixels will be 50 multiplied with 1 by 96 inches. This is how the pixels are calculated. Let me also give some padding. I'll say about 110 pixels and margin about 30 pixels, 50 pixels. And you can see the result. Let's add a few more properties. I'll give width 200 pixels, height 150 pixels and border radius 50 pixels. And this is how the pixel unit works. The question is, what is 1 pixel equals to in inches? So 1 pixel equals the 96th part of 1 inch. The PT, that is point unit of measurement, came from the typography industry, and that's why in most cases it is used for declaring font sizes. A point is a unit of measurement used for real-life ink on paper typography. 72 points make 1 inch. Here the 1 inch we are talking about is referred to with the 1 real-life inch, like on a ruler, not an inch on a screen, which is totally arbitrary based on the resolution. For the best cross-browser and cross-platform results for printing the content on pages, defining the point unit can be considered as a better option. Considering the accuracy with pixels, point sizes are more accurate on paper rather than displaying the content on the screen. So let's implement this unit practically. I'll define 2 paragraphs inside the body, having the class names as pixel unit and point unit respectively. Now let me apply font size and color to the first paragraph. I'll give 30 pixels to font size And for the second paragraph, I am giving the font size in points. I'll say 30 points. So you can easily compare the size difference of points and pixels. Of course, the pixel is the smallest unit, so it will be comparatively smaller than the point. The same difference can be observed when giving different properties to the elements like padding or margin. Let me add a border to both the classes so that it will become easy to compare. Let's say if I give 40 pixels padding to the first paragraph and 40 point padding to the second, you can see that the point unit leaves more padding space. Now let's talk about relative questions. So what is a point size unit in CSS? So the point unit is basically used for defining the font size. Points are the unit of measurements which are used when the content is to be printed on the paper. Points are based on an inch on a ruler, and 1 inch is equal to 72 points. The centimeter unit is used to define a length value to the properties which deal with shapes and sizes or spacing of the elements. Let's check it practically. We'll compare centimeter unit with pixels. So I will create two paragraphs inside the body. One will have the class name centimeter and the other as pixel. Now for the styling, let's set the font size of the first paragraph to centimeters. I'll give the font size property to 1.5 cm, and you can see the change in the size. Similarly, if I give the same font size value but in pixels, you can see the pixel value is hardly visible. As the centimeter unit also maps to the pixels unit, the value of 1 centimeter is equal to 37.8 pixels. So if I want to match this font size, that is the 1.5 centimeter to its corresponding pixel length, I would have to set it to 56.7 pixels, which equals 1.5 centimeter eventually. And you can see the font size of these paragraphs matches. Giving centimeter units might create a difference in output viewed from various devices. So generally, when you are building a web page which is specifically to be viewed from the computer screen, better not overuse the centimeter unit, as the output may occur differently when viewed from other small screen devices. So let's discuss a question here. What is 1 centimeter equals to in pixels? So as we saw earlier, 1 centimeter equals 37.8 pixels. The mm or millimeter unit in CSS is a magnitude lower than the centimeter unit. 1 mm equals 1/10 of a centimeter, and that equals 3.78 pixels. The use of the mm unit is similar to the centimeter unit. It is particularly used when the content is to be displayed on any printing media platform, as the length size expressed with this unit is very precise and accurate. So in the front-end community, the mm unit is not recommended to be used for displaying contents on screen, as the screen sizes may vary, which results in the content not getting displayed properly. Let's check an example. I'm going to create 3 paragraphs inside body with class name as millimeter, pixel, and centimeter. Now for the first paragraph, I'll give font size, let's say 7 mm. As the millimeter is 1/10 of the centimeter, the corresponding centimeter value of 7 mm will be 0.7 cm. So I will give the font size as 0.7 cm. And to match this font size in pixels, the pixel value will be around 26.46 px, as 1 mm equals 3.78 pixel. So let me give here 26.46 pixel, and you can see the result. Now let's talk about a practice assignment. Implement the CSS code to display the shown result. Looking at the result, you can identify that all these are just simple borders with different colors. So let me create a paragraph with some text and let's implement the style of it. Set the font size to 7 mm. Next, I will define the border top property to define the top border. I'll give the width in mm and color. Similarly, I will define 3 more borders, that is bottom, left and right, with the same width and different colors. Alright, we are very near to our goal. Let me keep the alignment of the text to center and we'll set some padding to create a little gap between the borders and the text. And at last, giving some margin from top, just so to make it set around the vertical center. And we have achieved our result. The inch unit in CSS is another useful unit when you want to display the content on the page, that is for printing the output on a paper. Inches are not widely used for displaying on-screen outputs as the result is not always accurate. The accuracy always depends on the screen of a particular device, and as we know, the device may vary, thus it may alter the final result in some cases. In CSS, 1 inch equals 96 pixels, which is about 2.54 centimeters. So let's take a look at an example. I will create 2 paragraphs. First paragraph I'll give class name as inch and second paragraph I'll name it as pixel. Now inside the style, giving the font size of about 0.5 inch to the first paragraph. If I give 1 inch, you can see how big the font gets, as 1 inch is equivalent to 96 pixels. So I will drop the size to 0.5 inch. Next, I will give the pixel value, and the pixel value for 0.5 inch would be 48 pixels. As 1 inch equals 96, 0.1 inch would be 9.6 pixels, and so the 0.5 inch or half of an inch would be 48 pixels. It's just some simple calculations, and as a front-end developer, it is very essential that you do some calculations before giving the values to any element. The pica unit is yet another typographic unit of measurement used for printing the content on a paper and is approximately 1/6 of an inch. Picas are equivalent to 16 pixels, and if compared with points, 1 pica is equal to 12 points, that is 6 picas per inch. So let's get on with the practical implementation of this unit. I'm going to create 3 paragraphs. We'll compare the pica, pixel and point units. I'll give the class names accordingly. Now inside style, I'll give 2 picas as font size to the first paragraph, and to define the pica unit, the P and C initials are used. And for the second paragraph, as to match the size of the first paragraph, the font size will be 32 pixels, as 1 pica equals 16 pixels, so 2 pica would be 32 pixels. Same thing would be applied for giving the size in the point unit, as 1 pica equals 12 points. So to reach the size of 2 picas, the point size will be 24 points. So this was about the pica unit and the end of the absolute units section. Once again, to summarize, absolute units are the fixed units. Lastly, I have created a simple chart of absolute units for you to remember them easily. When it comes to designing responsive sites, relative unit such as M is a must-have unit, as it gives adaptability and flexibility in sizes defined for fonts and elements. M, which is a short form for ephemeral unit, is a widely used relative length unit, as it can be used in any situation like setting up the font size or setting the length of any element like width, padding, margin, height, etc. It's very straightforward and simple to use, so let's have a look at an example. I will create a division and will define a paragraph inside. Inside styling, I'll simply give font size to the paragraph. Let's say 1.5 ems. Let me add a border as well. We will require a border here to understand an example as we move ahead. Alright, so you can see the increase in the font size. By default, the size of font is 1 em, which is 100%. When given an em unit as font size, the size of an element will always relate to the size given inside the parent element. In a shorter version, the ems unit is always relative to their parent. Like here, if I give font size to this div, let's say about 1.2 em, then you can see the overall font size of the paragraph is increased. So it's going to multiply the sizes of parent element and child element, that is 1.2 em into 1.5 em in this case. And the final result will be applied to the child element, that is in our case the paragraph. Let's see how padding is calculated when we assign em unit to it. First, let me justify the text so that we can see the padding properly. Now let me give padding here. I'll say 2.5 em. Now let me open developers tool. I'll click on computed and I'll select the paragraph. And you can see the padding of the paragraph is 72 pixels. How? The overall font size of the paragraph is 1.2 em into 1.5 em, that is 1.8 em. Finally, the padding of each side of the paragraph is 1.8 ems into 2.5 ems, which is 4.5 ems, which equals 72 pixels, as 1 em equals 16 pixels. Let's take one more example. I will change the font size of the div to 20 pixels, font size of paragraph to 1.25 ems, and padding to 2 ems. Now the padding is calculated like this. The overall font size of the paragraph is now 25 pixels. So padding will be 25 pixels into 2 ems, that is 50 pixels. So this is how the em unit works. There is also one more concept. Well, actually it's more of an issue where the em unit compounds from one level to another. I will show you what I mean. Let me remove this paragraph and I'll name this div as parent. Also, I will give a message. This is a parent division. Similarly, I'll have two more divisions as a child of the parent div. Now in the styling, let me give the class selector names and I will change the font size of parent div and child div to 20 pixels and 2 ems. If you observe the output, you can see the problem I was discussing. This issue is called the compounding effect, where the unit keeps on multiplying when there are multiple em font size elements within one another. This can become a problem and can lead to unintended consequences in your designs. This is where the rem unit comes in handy, and that we will learn in the next lecture, continuing with this example. Now let's talk about relative questions. So what is 1 em equals to in pixels? Generally 1 em always equals 16 pixels. But pixel is a static unit whereas em is a relative unit, which means the size of the em depends on the parent element as well. The second question is, what is em relative to, or why em is a relative unit? Well, the em is considered as a relative unit because the font size is relative to its parent element's font size. So if you wish to scale the element's size based on its parent size, you use the em unit, as it is also responsive in web designing. The third question is, apart from font size property, can the em unit relate with other properties of the parent element? The answer is no. When you declare an em length unit on padding, margin, width, or any other properties apart from the font size on the parent element, it does not affect the width, padding, or margin of the child element. There is also one more question, that what is the compounding effect issue when you are dealing with M unit? And we have already discussed, in this case it was compounding. The solution to that we are going to see in the next lecture. The rem is a relative unit which is always based upon the font size value of the root element, and the root element in HTML is the HTML element itself. That's why rem, that is short for root m. If the HTML element doesn't have any font size specified, then the browser will take the default font size, that is 16 pixels. So what this means is that by using the rem unit, the values of the parent elements are ignored and only the value of the root is taken into consideration. Let me continue with the previous lecture's example. The issue we were facing was the compounding effect, where the unit keeps on compounding when there are multiple m font size elements within one another. Alright, to fix this, I'll use the rem unit instead of m, and you can see just when I changed the unit to rem, all the child divisions share the same font size, that is 32 pixels. Why is it so? Because now the font size is not relative to the parent element, instead it is relative to the root element, which is the HTML element. And as the default size of the root element is 16 pixels, the division's font size got multiplied with 16 pixels, that is 16 pixels into 2 rem. If you want to change the font size of the root element, you can do that by giving the font size property to the HTML element. I'll say HTML here and will give font size to 12 pixels. Now the font size of all the child divisions is 24 pixels. And to check that, let me open the developers tool inside the browser. First, let me show you the font size of the root element. I will select the HTML tag and then I'll click this computed option, and when I scroll down you can see the font size, that is 12 pixels. I will select the child division next, and you can see it shows the font size 24 pixels. Now which unit to use generally depends on your personal preference. There is no better unit really. Some people like to design everything in rem units for consistency and predictability, while others like to use m units in places where the influence of nearby parent elements would make sense. Rems aren't only useful for font sizing. You can use the rems as a base for creating an entire grid system or any UI library on the root HTML font sizing using rem. This can give you better and predictable font sizing and scaling. I would like to add a bonus tip here. There are some browsers which still do not support the rem unit, and to avoid this kind of compatibility issue, we specify the fallback by defining the pixel font size first and then the rem font size. You can see as our browser is compatible, it relates to rem font size, but if any browser is not compatible with rem, it's going to take the pixel value. So let's talk about the questions. What is a rem unit? So the rem is a relative unit which is relative to the root element, that is the HTML, not to its parent element. The next question is, how many pixels are there in one rem? If there is no size defined inside the root element, that is the HTML element, the rem is going to take 16 pixels by default. So one rem equals 16 pixels. The next question is, explain the compatibility issue faced while using the rem unit and how can you resolve it. So I have just discussed in the bonus tip that certain browsers still face the compatibility issue with the rem unit. So to avoid that situation, we define the font size in pixel value first as a fallback and then again define the font size in rem. So when the browser fails to recognize the rem unit, it will consider the pixel value. The font size defined in percentage is relative to its parent element's size, and a parent element size can be either absolute or relative, that doesn't matter. 100% equals 16 pixels. Let's check few examples. I'm going to create a division as a container, and inside I will define a paragraph. Now let me define a border for this division inside style, so we can have a clear idea about the area getting covered by the division. Next, I will define the font size of the paragraph, say about 250%. Now I will give font size to the division. I will say 120%. And you can see the increase in size as the paragraph is now relative to the font size of the division, which is its parent. Let's make the font size to 150%, and the font size of the paragraph increases again. Let's give a different property, say width, but first let me give a border to the paragraph so that you can see the changing of the width. Now I will give width to the paragraph and to this div as well. I will say 350 pixels for div and 80% width for the paragraph. Now what's going on here is the width of the parent element, that is div, is getting multiplied with the width of paragraph, that is 350 pixels into 0.8, and the overall width is applied to the paragraph. Let's add few more properties. I'll apply margin to div, top and bottom margin. I'll keep 30% and right and left margin to 25%. Lastly, I'll add padding to the paragraph, say about 5%. Percentage unit in CSS is very handy when it comes to positioning the elements on the page. Most often they are used in creating fluid layouts. What are fluid layouts, you may ask? A fluid layout is a type of a web page design in which layout of the page resizes as the window size is changed. Most of the page components in a fluid page layout adjust to the user's screen size by using percentage widths rather than fixed pixel widths. Let me create another simple example. I'll define two divisions. One, we will keep it fixed by using pixel values, and for another, we are going to make it a part of fluid layout. Now for fixed layout, I'll define border width about 400 pixels and padding of 50 pixels. Similarly, for fluid layout, I will define the same properties but in percentage units. Now watch this. When I resize the browser, you can see that the fixed division is not adjusting to the browser's screen, while the second division is adjusting as per the browser's screen. This is what creating a fluid layout looks like. You can also give the percentages to create flexible images. By doing so, the image will also adjust with the browser screen. So this is what working with percentage looks like. There are some properties which do not accept the percentage unit. For example, border width. Let me apply border width to the division. I'll remove this pixel width from the border and I'll give percentage width about, let's say, 12%. You can see there is no change in the width of the border. Now if I change the unit to pixels, the given width is getting applied, as you can see. Remember, the percentage unit shows the relevancy with the parent element. The X unit is defined as the X height of the current font, or half of 1 1 X height equals 6 pixels. The X height of a given font is the height of the lowercase x of that font. As you can see in this figure, the X height is the height of a normal lowercase letter in a line of text. Generally, this is the height of lowercase letters, but there will be cases where certain letters exceed the X height but that depends on the font family as well. In the typographic dimension of design, the height of letters has important spatial relationships to the rest of the elements. The lines shown in the figure are intended to help for pointing out the X height of the text. The X unit is similar to the M or rem, as it also relies on the current font and its size. However, unlike the M and rem, this unit also relies on the font family, as they are highly based on font specific measures. Let's check an example real quick. Let me define two paragraphs with class names X height and pixel. I will give the font size to the first paragraph as 9x. Now, as 1x equals 6 pixels, the related pixel value for 9x will be 54 pixels. So I will give 54 pixels here as font size of the second paragraph. You can see some difference in the output. Why? Because as I have mentioned that the X value is created using the font specific measures, that means the X unit is highly dependent on the font family. Now when no font family is specified, the HTML page will load in its default font family, that is Times New Roman, and the X unit renders these fonts in different size ratio compared to the pixels. This is why the X units are rarely used in front-end development. I have covered this topic because it's very essential that you should know this kind of unit as well and have some idea about working with them. The CH unit, which stands for character unit, is a unit that lets you limit the width of text elements by character count. More specifically, it is defined as being the advanced measure of the width of the 0 character for a given font. Let me show you what this means. I will create a simple input inside the body. I'm going to style this input by giving border radius to 0.6 rem, font size 2em, margin 2 rem and padding 0.4 rem. Now when I give the width 10 ch, the input will adjust in a way that only the first 10 characters are going to be displayed on the screen, and the unit ch sets the width of characters considering the space taken by the character 0. Let me give proper digits. I'll give 1 to 10 digits, and when I add the 11th digit, then the first digit gets hidden. So again, only 10 characters are seen here. Let's try alphabetical letters. I'll change the width to 15 characters and giving the alphabetical letters until I fill up the given width. Alright, so now what do you see? If you count the letters, they are exceeding the range of 15 characters. Why is it so? Because the CH unit takes the character 0 for setting up the width. So let me give zeros instead of these letters. And now you can see 15 character sets the width, which takes up to 15 zeros. You can also set the width of a paragraph. Let me define a paragraph and give font size. We'll set the width to 50 characters. By doing this, the line will never be longer than the equivalent length of 50 zero characters for this font in this font size. This lets you customize the user interface with limited characters. As a developer, it is a good practice that you declare a parent container with some desired width, and then you can assign width in character to the inner text elements. By doing this, it will be easy for you to customize and manage the code. You can also define the character unit with different properties as well. It's just that there is no constant pixel or any other value which relates to ch, that is character, as the character is a relative unit and it equals the width of the 0 glyph in whichever font you are using. The VW unit, that is the viewport width, works just like the percentage unit. Viewport units have been around for quite a few years now since it was first introduced in CSS. They are considered as truly responsive length units because every time when the browser is resized, their value changes accordingly. Let's first understand what a viewport is. The viewport is defined as the user's visible area of a web page. The viewport varies with the device and will be smaller on a mobile screen than on a computer screen. Basically, viewports are used to customize the layout in a way that it fits well on the screen. There are 4 viewport-based units in CSS: VW, VH, Vmin and Vmax. In this lecture, we will understand the viewport width, that is VW. The viewport width unit is based on the width of the viewport, and the value of one viewport width equals 1% of the viewport width. So the 20 VW will be equivalent to occupying 20% of the entire visible screen width. Let's see this practically. I will define an empty division and will give background and height inside style. Now if I give here 30 viewport width, you can see it occupies 30% of the browser's width. If I change it to 60 viewport width, then it's going to occupy 60% of the browser's width. In many cases, viewports may work similar to percentages, but they are still very different from one another. Let's check another example where I create a parent-child div for applying percentage values and viewport width values. I'm going to define a parent div. Let me name it as parent percentage div, and a child div, I'll name it as child percentage div. Similarly, I will create another parent-child div, naming it as parent viewport div and child viewport div. Now let's style the parent percentage div. I'll apply background, height, width. I'll keep 50% top and bottom padding and margin at the last. For the child percentage div, I'll give background, height and width 80%. Here the width of the child div is relative to the parent div. That is, the width of the parent division is 50% and the child division is 80% of that 50%, as you can see. Moving on, I'll keep the styling of the parent viewport div and child viewport div the same as mentioned above. The only change will be in the width of the child viewport div. I am going to give 80 viewport width to it. And now what do you see? The child division is wider than its parent division. You may raise a question, why is it so? Isn't 80% the same as 80 viewport width? Well, this is what the viewport width does. It removes the dependency of any parent element and allows sizing based on the viewport size of the browser window. In simple words, a percentage length is relative to containing element width, while a viewport width is relative to the full width of the browser window. The viewport height, that is the VH unit, is based on the height of the viewport. It works just like the percentage unit as well. The value of one viewport height equals 1% of viewport height. So specifying 20 VH, for example, will be equivalent to occupying the 20% of the visible screen height. Assume that we have a viewport whose overall height is 300 pixels. So when the height of 40 VH is applied on the viewport, then it will be calculated like this. Though viewport works just like a percentage unit, setting up the height in viewport and percentage is still very different. To understand that, let's implement an example. I will create 2 headings inside the body, giving heading 1 as viewport height and second heading as percentage height. Now let's style them. For H1, I will first apply the display property and will set it to inline block, as I want these two headings on the same level. Then I will apply font size, border, width 42 VW and height, let's say 70 VH. Let me give some margin as well. Now there is a simple trick to calculate an accurate margin which relates to the viewport of the window, and that is you subtract the given height from 100 and further divide that value by 2. In our case, the height is 70 VH, so the margin value will be 15 VH. Now let's style the H2 as well. I will duplicate the H1 styling and rename it as H2. I will just change the height to 70% and keep others the same. And you can see both headings are displayed. But did you notice that the height of the second heading is not getting applied? The reason is the percentage value is relative to its parent element. So we have to give height to the parent element as well. And here the parent element is the body tag. So let me give height to the body. I will say 100%. And still you can see the height is not getting applied because the body also has a parent element, and that is the HTML tag itself. So I will add HTML tag with height property as well. Now you can see that the height is getting applied on the heading. So when you give the percentage value, you will have to keep in mind that it relates to the parent element as well. While with the viewports, the height and width relies on the overall screen size only. So this is what working with viewport height looks like. While VH and VW are always related to the viewport height and width respectively, Vmin and Vmax are related to the maximum or minimum of those widths and heights depending on which is smaller and larger. Vmin represents the value of the minimum width and height of the viewport, while Vmax, which is exactly the opposite of Vmin, it calculates the value based on the maximum height and width of the viewport. In Vmin, if the viewport height, that is the browser's height, is smaller than its width, the value of 1 Vmin will be equal to 1% of the viewport height. Similarly, if the viewport width is smaller than the height, the value of 1 Vmin will be equal to 1% of the viewport width. In Vmax, if the viewport height is larger than the width, the value of 1 Vmax will be equal to 1% of viewport height. Similarly, if the viewport width is larger than the height, the value of 1 Vmax will be equal to 1% of the viewport width. Consider this example where we have this screen in landscape mode having the width of 1920 pixels and has the height of 1080 pixels. As the width of the viewport is greater than its height, 1 Vmin will be 10.8 pixels and 1 Vmax will be 19.2 pixels. Similarly, 10 Vmin will be 108 pixels and 10 Vmax will be 192 pixels. Now if the screen is rotated, the viewport becomes 1920 pixels high and 1080 pixels wide. Then 10 Vmax will be 192 pixels because now the value is calculated based on the viewport height, and 10 Vmin will be 108 pixels. Just to clarify that, 1 Vmax equals 1 VH in portrait mode, and in landscape mode 1 Vmax equals 1 VW. Now if the screen is resized and the width of the viewport becomes 900 pixels wide and 1600 pixels high, then the value of one Vmin and Vmax will be 9 pixels and 16 pixels. Similarly, the value of 10 Vmin and Vmax will be 90 pixels and 160 pixels. The value of Vmin and Vmax change whenever the browser window is resized. This is how the Vmax and Vmin units function. Let's check an example. I will define heading and a paragraph, and now let's style them. For heading, I am giving font size of 10 Vmin. It will consider the viewport of the browser window since I am not specifying any height and width to the document. Next, I will just align the heading to center. For the paragraph, I am giving font size 3 Vmax and width about 90%. Alright, now when I resize the window, you can see the font size is getting adjusted continuously as the viewport keeps on changing. If I change the unit to, let's say, rem and m, now if I resize, you can see it is not getting adjusted as the rem and m are not related to the viewport. So this is what using viewport unit looks like. Let's talk about a question. So explain what Vmin and Vmax is. Well, they are units. Vmin represents the value of minimum width and height of the viewport, while Vmax, which is exactly the opposite of Vmin, it calculates the value based on the maximum height and width of the viewport. Next question, what will be the value of Vmax and Vmin if the height of the viewport is larger than its width? So if the viewport's height is larger than its width, then the value of one Vmax is equivalent to 1% of viewport's height, and the value of one Vmin is equivalent to 1% of the viewport's width. In CSS, you may come across situations where you have to set an angle measurement for particular elements. CSS provides us with 4 different angle measurement values expressed in degrees, radians, gradients, and turns. Degrees range is from 0 degree to 360, and you can define it either in positive or negative. Negative degrees go counterclockwise, that is, it will turn to its left side, whereas positive degrees go clockwise, which is to its right. The rad or radian represents an angle. 1 radian is equivalent to 180 by pi degrees, or about 57.3 degrees. A radian creates an angle on the circumference of a circle in an arc shape, which is of equal length to the radius of the circle. One full circle is of 2 pi radians. Half a circle is pi radian, and half a circle in counterclockwise direction is minus pi radian. Next we have gradients, that is grad, which is equivalent to 1 by 400 of the full circle. Similar to degrees, a positive grad value will go clockwise, a negative value goes counterclockwise, 100 grad will be at 90 degree angle. Minus 200 grad will be at 180 degrees, and so on. Finally, the turns unit. This unit is a newer concept which is introduced in CSS 3, and it means rotation. 1 turn is equal to 360 degrees. 2 turns is 720 degrees, and so on. Turn is a singular, and there is no space between the number and its unit. As the browsers got updated and started showing compatibility with animations and transitions of shapes or elements, the angle measurement units were introduced, and now they are equally important as length units. These units are majorly used with the properties like animation, transform, or gradient properties such as radial gradient method, linear gradient, conical gradient, also used with functions like skew, translate, rotate, scale, etc. All these are advanced concepts which I will cover as we move along. So this was about the angle measurement units in CSS. Time measurement units are very easy to understand and implement. CSS provides two time measurement units, seconds that is S and milliseconds that is ms. These two units are used with the properties that require to specify the duration of something like animation or transition. There are 1000 milliseconds in a second. The format of a time value is a number followed by S for seconds and ms for milliseconds. So let's have a look at an example. I'm going to create a division inside the body and apply styles to it, giving background color, height, width, and border radius. You can see a circular shape in the output. Now I will create a hover effect on it. I will give the hover pseudo class here, adding a different color along with a transition of 0.8 seconds. Now when I hover on this division, you can see the color is getting changed, but with a transition of 0.8 seconds. So this is where the time units are used. I can also change this time unit in milliseconds. Let me give 800 milliseconds. And you can see the transition effect. The use of seconds or milliseconds is totally up to you. There is no comparison of which unit is better. These units are majorly used with transition property and with the animation property. So this is how the time measurement units come in handy. Remember that you cannot give negative time values. They must always be positive.